Hello, everybody. So again, it's pleasure to present different topics in data visualization, namely multidimensional data visualization for big data storytelling, and we will discuss direct methods in this webinar. Again, this webinar was prepared by Professor Tomas Krilavicius and Monika Zdanaviciute, both from Faculty of Informatics at Vytautas Magnus University, Lithuania. So let's move on. And of course, in previous webinar, we have discussed simple methods, basically to visualize one or two dimensional data. However, most of the time, data is quite complex, and usually we have multidimensional data. So, for example, we can have product, location, time, and a lot of other dimensions. And then in such a case, it gets very complicated to visualize data because it's very hard to imagine something that has, let's say, 4 and more dimensions. So what you have to do, you have to find a way to visualize the specific type of data. And in this lecture, we will look at different types of charts or plots which allow to visualize multidimensional data. So we start with scatter plot. In general, of course, scatter plot is used to visualize two-dimensional data. So like in this example, Monika.
So in this scatter plot, we can see a relation between amount of ICH elements, which is intangible cultural heritage elements, and the number of tourists in a country in 2019. So here we cannot see like a very clear trend, but we can guess that it is a positive correlation between these two variables because the bigger the ICH element number is, we can see that the higher number of tourists are in these countries.
Okay, so let's move on. So basically what it's about actually these scatter plots. So you have two variables and you depict your values. Let's say what happens when you have crossfit between variable A and variable B for an object. And then, of course, these points, basically we represent different observations or objects. And what you have, you can see actually, how we are distributed, what are the strange points or dots in this visualization, etc. And usually, of course, you have cloud of or line or cloud of dots, and when you have dots which are far from everything, so these are usually called outliers. And one of the such examples, Monika.
Yes, so here we can see that we tried to fit the best line for this correlation. And as we can see, it is positive correlation. And to see if it is good correlation or it is just very small, we need to see other graphs and just to see better.
Okay, so as you see, I mean, not always data helps you, and not all visualizations are very useful. So, for example, in some cases, actually, you may have to zoom in or to remove some outlier points which actually do not allow you to look deeper in what's happening inside. But basically, what you can see when you build such scatter plot style visualization. So, what you see, you usually see different how these two variables correlate or how these two features correlate. And then different distribution of the points in this visualization show very different ways of correlation. So for example, if we start from the left top visualization, we see very clear, very strong positive correlation. Basically, both of the features are growing, while the middle green visualization, here you see strong negative correlation because while one variable goes up, another goes down. And in some cases, of course, you don't have any correlation at all. So basically, But you can see that while one feature changes, another feature remains more or less the same. It means that basically you cannot tell anything about one feature from another. Then, of course, you can, based on the distribution of the points, again, you can see that in some cases it could be more linear, like depicted here. In some cases, it could be exponential, U-shaped, circular, or whatever. So again, you see what kind of stuff you have there. And then, of course, it shows also strength of correlation. So, for example, the bottom left visualization shows very strong correlation because, as you see, it's almost one line with very small distribution around. In the middle, you see weak correlation. As you see, dots are quite distributed in the whole area. And the right visualization, basically, as you see, we don't see any dependency between these dots, so there is no correlation. And then, of course, the next step is to move further. So basically, when you deal with multidimensional data, what you usually do, you try to look at correlation between all the features of these data. And what you get so-called matrix of scatter plots or trellis. So basically, you just get a lot of scatter plots which show relations between different features of this data. It's one of the basic tools for data scientists, for statisticians, because often or most of the time they build such visualizations just to explore the data, to look what's happening there. And the next visualization, it's more colorful, and here, of course, you can have two or more dimensions, and again, you see relation between different values, so it's so-called heat maps. And in heat maps, what you have, basically, color shows the strength of relation. And here, actually, in addition, you also have clusters, so grouping of the cars, and then you see different characteristics of cars and how strongly they relate with different models. And of course, you can use such visualizations to depict tourism information data. Monika, please.
Yes, so here we can see the correlation between number of intangible cultural heritage and number of tourists. So as we can see, the color of these areas is quite bright, and we can see numbers that is above the 0.5. So it's positive correlation, and we can see that when over time the correlation is being more strength.
Yeah, so basically it's quite easy to see the continuous growth with some fluctuation, and in some sense it shows that actually number of events really, influences number of tourists. So in a simple manner, it shows that if you want to have more tourists in your country, you need more events. And one more visualization, more details.
Here we can see the correlation between number of specific ICH elements such as food, events, dance, and music. And we can see that one type of ICH element could be more, could correlate more than another. So we can see that the events and music rows are brighter. So that means that the correlation is more, relation is more strength. And for example, the dance shows a weak correlation because the color is very light.
So basically, again, how it's useful. So actually, of course, very carefully, you can claim that Actually, if you have high correlations, it means that organizing such event may influence and may increase number of tourists more, while, for example, in this case, organizing dance events, its influence is not going to be so strong. But again, for example, in case of dance, we see very slow growth, while music, there is also some growth, while in general in events, it kind of fluctuates but grows as well. So it seems that actually sharing information about different events, it also allows to increase number of tourists, but depending on events, you can expect more or less tourists as well. And one more
Here we
lot
can see
of
one
correlations.
more heat map. So here a correlation between number of specific ICH and the change of number of tourists. So here we can see how between the specific ICH and change of number of tourists. So we can see that the correlation of tourists changing over time, it's not that big. It's actually very weak, and the colors are very light, so that shows us that.
Yes, so basically, if you look at such factors, you cannot claim anything strong by looking just at them. You have to investigate these relations deeper. Then let's move to another way of visualizing data. So these are so-called graphs, and graphs are very well known. Of course, you may know them by different titles. So for example, of course, when maybe you talk about World Wide Web, you may talk about computer networks, which are actually graphs. In some cases, when we think about phone networks, it's more or less the same. Actually, when people talk about social networks in general, social networks can be represented as different graphs, but also state machines, which are already used to represent dynamics or processes, not just the relation between different objects, or even organizational structure, which may show some hierarchy. And basically, graphs can be used to represent specific data where we want to represent relations between different objects, or maybe flow of something from one object or another, processes. In addition, we can add, for example, importance of these relations. So if we start from the simplest graphs, we have so-called undirected graphs. And of course, we can be represented as matrices as well. Basically, what we just show relations between different objects. And of course, by visualizing them, you can see already quite a lot of features. So for example, you can see objects which relate only with few other objects, or like object A here, it has direct relation with 5 out of 6 additional objects. And if you take transitive relations into account as well, it's related with G as well. In addition, what you can have directed graphs. So basically in directed graph, you already have directions. So while in undirected graphs, we talked about just relations between A and B, or two objects. In this case, it could be, states or something like that. And actually, you can have relations which are one-sided. So, for example, in this case, A is related to B, but B is not related to A because we don't have arrow backwards, etc. And then in addition to these, directions, what we can do, we can have importance of this relation. So the higher is the importance, the higher is number. And then, of course, we can, for example, if we look at this importance, maybe we can remove some edges because we are not so important. And of course, we can move on and on. So we can have multigraphs when we have different types of relations depicted as edges. Then, of course, it could be weighted, directed graphs, etc. So It really depends on what you want to achieve by using graphs to represent data. And some examples how it could be used. So maybe it's not really tourism data, but it's related with cultural heritage and literature. So basically you can look at different characters in the literature. For example, here we can see Shakespeare, different creations of Shakespeare. And you can see, for example, which characters are the most important, which are mentioned a lot of times, which are just appear sometimes, and their relations. So again, you can see, let's say, central characters, characters which know almost everybody, etc. And of course, here it's example with literature, but the same can be done by analyzing different relations between different events, countries, people, etc. And of course, you can have very specific versions of graphs. So it's so-called tree. And in case of trees, you do not have cycles. And they can be used to visualize very different stuff. But basically what you have some kind of hierarchical structure. It could be from top or from the bottom. You start from some root. And for example, in this case, we see how we merge some objects together into one object. But if you look usually at hierarchical structure of some state or organization, you see the main leader at the top, and then you see lower echelons below. And of course, you can have something that is called forest. So basically, it's just several trees. And as I mentioned, they are very common and they are used a lot, for example, in biology to represent dendrograms, or it can be used to represent very different taxonomies. Then mosaic plots. So basically, in mosaic plots, again, you have some grouping. So in this case, for example, we group ICH elements into two groups, and we group tourist numbers again into several groups. And then we see what is the distribution among them. So Monika, please.
Yeah, so here are the countries grouped into 9 groups, and columns are grouped by ICH element numbers, and rows are grouped by tourist numbers. So in the middle, we can see the countries, the biggest group of countries which has less than 14 ICH elements. And we can see that this group is actually grouped into 3 groups, but the upper blue is very, very small. So that means that there is very, very few countries that has less than 14 ICH elements and more than 114 millions of tourists. In this group where countries has less than 14 ICH elements, their biggest group of countries has more than 7 million tourists, and tourist number between 7 million and 14 million. And we can see the third column, which is actually we can see that it is all blue, which means that the countries which has more than 28 ICH elements, almost all of these countries has more than 14 million tourists per year.
Okay, thank you, Monika. And basically what you can see, we already look at higher number of the dimensions here. Of course, this mosaic plot, or sometimes it's called Marimekko chart, it's already needs some understanding of how this visualization works, and it needs some additional explanations how to comprehend it. And one more example of mosaic plot.
There are same tourist number groups, and they're changed over time. So we can see that the red group, which is tourist number less than 7 million, is growing, and the green group, which is this is less than 7 million tourists per year, is decreasing over year.
Okay, so let's move on. And of course, we can have a lot more complex visualization tools, so-called Sankey diagrams. So basically, we take this example from our colleagues from Canada, and they built some visualization of 2014-2015 Ukrainian events about improvised explosive devices. But what you can see here, you can see different features again as columns, and you see how these different features, different values relate with each other. And here just small snapshot of it, but basically you can visit their website and see more details of what's happening there at that period of time and what kind of explosive devices were used. So it's a bit gruesome, but visualization, quality of visualization is very good. And also it includes all stories. So basically what we mentioned before and what will be mentioned in these webinars a lot more, that your visualizations should tell some story, give some explanation of what was happening and how it's happening. But let's move further on. So in addition, what we have so-called parallel coordinates. Again, here we use classical Fisher iris data. And the idea is that we have, let's say, several types of iris. So in this case, Setosa, versicolor, and virginica. And we look at their sepals and petals properties. And when we try to look, can we somehow identify these types of iris by just looking at specific features? And in this visualization, basically, again, we have a higher number of vertical axes. So each vertical axis represents some specific feature. And when you depict object, basically you start from one axis, and then you connect these, values of features on each axis to represent the objects. And here color is used to represent categories. So basically we have 5 dimensions in this case. So categories, and then sepal and petal properties, width and length. And well, it's visible that sepal width is very bad predictor, but petal length really shows that, for example, virginica has longest petals, while Setosa has shortest ones. And of course, you can have a lot more features here, but still it's limited number of them. So basically, as I mentioned, in parallel coordinates, separate vertical axis is used for each separate feature or dimension. Again, it's useful only for a limited amount of features and data, as with all direct multidimensional visualization methods. And of course, you can extend these visualizations. So you can do hierarchical parallel coordinates where you cluster the data, then you use line connecting values as clustered centroid, and the further the value from the centroid, the lower is the rightness, like in this case. And as you can see, it's kind of gives better view of distribution of these features of different irises. So to conclude part about direct multidimensional visualization methods, so multidimensional visualization methods may require preliminary understanding. What I mean by that is that if you just show that everybody, you may have to explain what does it mean. You have to use a lot more additional explanations, but still it helps to understand relations between different features or different dimensions. Again, there are a lot of different methods. We just show here some of the most popular ones. And as before, methods which give the best answer to your question should be used. And as usual, different methods work better or worse for different audiences or using different tools. So for example, one method could be better if you use it on big screen, while another could be better to use on small screen. If you want to print something, again, another approach may be more useful. And when we talk about quality of visualization, we start with question. When we take data, we estimate quality of the data. To get good results, quality of the data should be sufficient, and it should contain important information. And when you have question and data, based on that, you use visualization as a tool to get answers to your questions. So thank you for participating in this webinar.